Hello everyone. So today we are going to discuss about the Boltzmann machine. Boltzmann machine. It's one of the neural network. Okay. So it is nothing but an unsupervised deep learning model. Okay. So this Boltzmann machine model comes under the unsupervised deep learning model. Okay. In which every node is connected to the every other node. Okay. So all the nodes is connected to the each and every node. Okay. It is a type of recurrent neural network. Okay. So these machines are not a deterministic deep learning model. Normally this Boltzmann machine comes under the stochastic or generative deep learning models. Okay. So their representation of the systems, maybe there are two kinds of nodes we are following in the Boltzmann machine. So one is nothing but the visible node. Okay. There are nodes that can be measured. Okay, so that is for the visible nodes. Second one is for the hidden nodes. These are the nodes that cannot be measured. Okay, so there are two kinds of node we followed in the Boltzmann machine. Okay, so the main purpose of the Boltzmann machine is to optimize the solution of a problem. Okay, if there is any problem, okay, so that problem we are going to optimize. Okay, we have to maximize the value or minimize the value. That is called as optimization. Okay, for this optimization purpose, we are using the Boltzmann machine neural network. Okay, so it is the work of Boltzmann machine to optimize the weights and quantity related to that particular problem. Okay, so see, so this is the architecture of the Boltzmann machine. Okay, so what about here? So we are having the neuron, input neuron and output neurons. So all the neurons is connected to the all other neurons. Okay, so this neuron is connected to the here, and this neuron also connected to the other neuron, all the other neurons. Okay. So and this neuron, each neuron has its own values. Okay, there are two weights will be considered. Okay, so the unit within each row and column are fully interconnected. So each row and column are fully interconnected. The weight on the interconnection are given by the minus p. Okay, so where the p is greater than 0. Also, there exists a self connections of each unit. Okay, this is for the self connection of each unit b. Okay, so that weight we have to represent by b, represented by b. Okay, so that is the b value is greater than 0. Okay, so the unit xij is a common unit. Okay, on which our discussion is based. Okay, so the weight present on the interconnections are inhibitory. Okay, so all the weights are in negative. Okay, minus p means that is for its inhibitory weights. So each neuron have the connection link. Okay, through the connection link it is connected to all other neurons. Okay, and it has the own weight also. Okay, that own weight is simply generally we call as that values are in bias b. Okay, that values are greater than 0. Okay, so the connection between the each neuron. Okay, so that weight is we called as inhibitory weights. Okay, so from that, okay, we have to find out the testing algorithms. Okay, so you have to calculate this wij. Okay, the weight value. Okay, so that is why it's a minus p. When it is minus p means if I small I equal to I or small j equal to capital J. Okay, but not in both. Okay, or otherwise that weight value is equal to b. Okay, so this testing algorithm is nothing but for the step 0. First step you have to initialize all the weights representing the constraints of the problem. Okay, also initialize control parameter t and activate the units. So this will be considered as a first step. Okay, not in first step. This is for we have to consider as 0th step, initialization and all. Okay, assign the value, that is will be considered 0th step. For this first step, when the stopping condition is false, perform step 2 to 8. Okay, when stopping condition is false, perform 2 to 8. Step 2 to 8. What is step 2? Perform step 3 to 6. Okay, in n2 times. Okay. So this for is nothing but the epoch or in iteration. Okay, so what is step 3? Integrates I and j or chosen random values between 1 and n. Okay, step 4 is calculate the change in consciences. Okay, the change in consciences we have to calculate by using this formula. Okay, so then step 5, I have to calculate the probability of the acceptance of the change in state. Okay, so how to calculate? So there will be 1 divided by 1 plus expansion of the minus del CF divided by T. Okay, by using this formula, I have to calculate the probability of the acceptance. Okay, then steps 6, decide whether to accept the change or not. Okay, decide whether to accept the change or not. Let R be the random number between the 0 and 1. Okay, if it is accept the change means, okay, when R is less than AF means it will be accept the change. Okay, if R is greater than or equal to AF means you have to reject the change. Okay, so this is for the condition. On step 7, reduce the control parameter T. Okay, so the T new I have to calculate, that is for it's a 0.95 into T volt. T new equal to 0.95 into T volt. Okay, on the last step, test the stopping condition. Okay, so which is if the temperature reaches the specified value or if there is no change of state for the specified number of epochs, then stop. Okay, otherwise continue. Okay, so this is the concept of the Boltzmann machine. Okay, thank you.